In section 5B, we are asking, should we believe statistical studies? In this section, we will discuss 8 steps for evaluating studies. Now, I'd encourage you to pause the video, and I want you to read through these 2 completely made up stories, and we're going to compare some of the differences between them. So after you've given yourself some time to read through those, I want to point out a few differences between Study A and Study B. In Study A, 12 patients were used from a single family, whereas in Study B, we had thousands of participants. 1,780 of those were randomly selected from that group. Study A, this was from a single family, so perhaps common family members could have similar results, whereas on the right, the participants were selected from each of the 50 U.S. states. So this perhaps is more representative of the population of the United States. The length of the study on the left was 2 weeks. Patients were examined and observed for 2 weeks, whereas on the right, we see that we had thousands of patients and they participated for 1 year. The study on the left, you'll notice that there's really nothing in here about a control group, whereas on the right, we did have a control group, and you'll see that half of the patients were randomly chosen to be in the treatment group and half in the control group. The experiment was a double-blinded group so that both the participants and the doctors were not aware of who was being given the treatment or who was in the control. Another sentence to point out. The doctors on the left were paid well by pharmaceutical companies that could have benefited from the results of the study, whereas on the right, the study was a joint effort by 20 different hospitals across the United States. The implications of this perhaps are benefiting patients, but not a particular company or business that would make us concerned. Doctors compared before and after CT scans of each patient in order to produce conclusions, so looking at those results, whereas on the right, it looks like our measurement here for the success of this treatment on the left, surveys. So in survey questions, patients were asked to rate their answer to the following question: how great are you feeling today? And we've talked about surveys a little bit already. That seems like a question that is trying to lead to one particular answer. And a survey certainly, so that while this is observational, this may not be the best measurement, this best tool in order to determine the effectiveness of the treatment. To get a better understanding of what we look for in scientific studies, we're going to take a look at 2 retracted studies. The first study here is linked in Blackboard. This study is, so this is comments referring to the retracted article about a study that was published in the late 90s. This was popularized by many rich benefactors and contributed to a decrease in MMR vaccinations that we see to this day. So the main author here was Andrew Wakefield. There were 12 additional colleagues that were co-publishers or co-authors on this paper. The conclusions of this paper suggested that MMR vaccines lead to autism in children. This paper has been retracted, and the main author was found guilty of dishonesty. He still remains a critic of vaccinations to this day and still has followers as of 2021. So let's take a look at this study and some of the reasons why this paper was later retracted. The first thing I want to point out is that we see a small sample size here. N equals 12, so we often use the letter N to denote sample size. If we have 12 children in this sample, that may not be a sufficient number if our population is intended to be the entire population of children around the world. The second thing I want to point out, this was an uncontrolled study. There was no control group versus a treatment, separate from a treatment group. This was an observational study. Wakefield had failed to disclose financial interests that later were surfaced. So Wakefield had been funded by lawyers who had been engaged by parents in lawsuits against vaccine-producing companies. So they could have benefited from particular results of the study. This could have led to bias in the results. Wakefield was found guilty of ethical violations. So beyond what you see here, there were some possible violations in recruitment of the children. So as you can see, this is a textbook case of what not to do. So this document is an example of what we do not want to see in a scientific journal. We'll look at one more. This is again a retraction. In this original article, the authors suggested a lowered probability of pregnancy in females aged 25 to 29 who had received the HPV vaccine. This was suggesting that the HPV vaccine was leading to infertility in females in the United States. One of the reasons that this paper was retracted is that the authors did not account for confounding variables in this study, such as education or birth control. So confounding variables can influence both your independent and dependent variables, and leaving those out could have indicated there was a causal relationship between the independent variables of having the vaccine and the dependent variable of pregnancy. However, not including these variables actually could have been explanatory variables in that analysis. So this paper was retracted due to serious flaws in the statistical analysis and interpretation of the data. So this is an example of when a scientist or statistician leaves out or omits particular confounding variables, which can severely damage the implications of those results. When evaluating a statistical study, it is important to get a big picture view of the study. Identify the goal of the study, as well as the population. Determine whether this was an observational study or an experiment. In an experiment, we do look for a control group and a treatment group. An observational study is sometimes used when it is not possible to have an experiment. Consider the source of the study. Were there any conflicts of interest? So maybe look for the money trail. So was the study potentially funded by a company that would benefit from the results of the study? Look for bias in the sample. And your book refers to two types of bias that we'll talk about a little bit more. So participation bias, you might look for how they chose the sample. Look for whether the sample was truly representative of the population. Try to identify any problems in defining or measuring the variables of interest. Were the variables defined properly and clearly? And were proper measuring procedures followed when gathering and reporting the raw data? Beware of confounding variables. So confounding variables are variables that can influence the independent and the dependent variables that are in the statistical analysis. If these are excluded from the analysis, then they can imply there is a causal relationship, though one does not exist. Now, sometimes confounding variables are impossible to determine or very difficult, but sometimes they're very apparent and common. And so in the study that we just talked about with the vaccine relationship to pregnancy, excluding education, though it is a known explanatory variable related to likeliness of receiving vaccines as well as pregnancy in females in the age group 25 to 29 could have severely influenced or falsified the relationship between that vaccine and pregnancy rates. And so that was an example of a confounding variable. These are variables that the researchers possibly did not take into consideration that could have caused different results. Consider the setting of the study. If there were surveys, consider the wording in the survey, the phrasing of the survey. So I've talked about a silly survey question that the doctors used in the study earlier, and that's a silly example that's to remind you to check the wording in the surveys. Sometimes surveys will have questions that seem leading to the patients or the respondents. Also, we want to identify if the wording in the survey was clear, and does the survey really gather accurate responses? Is the survey actually identifying and measuring the goal of the study? Check that the results are presented fairly. Does the data actually support the conclusion? So you want to recheck their data analysis here. And in 2020, we expect that a researcher will be very open and clear about their research so that we could replicate their analysis. And lastly, stand back and consider the conclusions. So take some time to actually consider, does the study achieve its goals? So these are the 8 steps for evaluating statistical studies.